Now moving on, there's a few other things about optics that are very interesting and important to us, and that is this somewhat recent, though not very, technical innovation of image stabilization, and that is more specifically optical image stabilization. And so what this tries to do is there's something inside, there's like a glass element inside of the lens that's attached to a circuit board, and this circuit board detects when there's movement that's occurring to it, and it tries to counteract that movement by moving this glass element to basically just counteract the movement that exists within your hands. And so what this can do is stabilize motion blur that happens as you try to hold a camera very, very still and try to take a photo. So as you can see from this example here, if we have IS off in the top image, it's somewhat blurry because we use too slow of a shutter speed perhaps to be able to capture everything that in sharp focus. But if we turn on image stabilization, then we can stabilize everything and it looks to be somewhat sharp. Now, modern image stabilization techniques or technologies can generally give you about what they refer to as 3 to 4 stops of stabilization. What that means is that whereas before, if you were only able to hold a lens at a particular focal length, so if you remember that rule that I gave you where I said, okay, if you have a 200 millimeter lens, that means that you can hand hold that image sharp at about 1/200th of a second. Well, that means if you get 3 to 4 stops additional stabilization, that means that you can go 3 to 4 stops slower than that. So that's 100th of a second to 50th of a second to 25th of a second. That's 3 stops to even maybe about 1/13th of a second. So now, whereas before you were only able to hand hold it at about 200ths of a second, you now can do it at a much slower speed to stabilize the image. Now, one of the things that's really important to realize about this is that it doesn't stop motion. It only stops your motion. Okay? So if there is somebody that's moving in the image, so if there's somebody over here and they're dancing and you're trying to take a photo of them, and you turn on image stabilization, you're like, oh yeah, I'm going to be able to stop time with this. It's not going to happen. You will only stabilize what's happening when you're hand holding that particular image. If there is somebody moving, realize that we've gone from 1/200th of a second, which seems to have reasonable stopping power in terms of motion blur. We've gone down to about 1/13th of a second. You can see that we're going to get a lot more motion blur from objects that are in the scene versus us being able to hold it. There's a very big difference here, and so people are always, people love to say, oh, I can have a really slow lens. I can have like f5.6, f8, and it really doesn't matter because I have IS to make up for it. You really don't. It does not make up for that. It only makes up for your inability to hold the camera very, very stable. And that says nothing about you because it happens to all of us. It's very hard to hold these things stable, but you're still losing that light. So keep in mind that while IS is a very nice technology, it doesn't replace the larger apertures that we get in these other lenses. Okay, so just to give you a more diagram, a better look at this using a diagram, what happens when in image stabilization is that if we are moving this lens and it's sort of moving up and down over here, then what we are trying to do usually in the lens is counteract that by moving a glass element up and down or in some other way. And in fact, there's new image stabilization technology that Canon just announced where it can also fix rotational problems as well. So if I don't even know when this would happen, but if you're rotating it very slightly, for example, it can try to fix that, which might be able to even have better stopping power. Now, realize that there's 2 forms of image stabilization. There's in-lens image stabilization, which is the case with Canon and Nikon cameras, and there's also in-camera stabilization, which you usually get, I think, with Sony cameras. And so with the latter form, you're not moving one of the lens pieces or one of the lens elements to try to counteract it. You're actually moving the sensor itself. And now you can say that this seems like it has quite a few advantages. For example, every lens that you put on your camera will therefore have image stabilization because it doesn't matter what kind of the lens doesn't have to have IS in it. If you have a camera body that has IS, you'll be able to counteract that motion. So therefore, it might be a bit cheaper because you're only paying for that technology once. And those are both very, very valid reasons to pick a system that has image stabilization in the camera body versus in the lens. But I would say that it really depends. So I think that by having image stabilization in the lens, the engineers can tune the stabilization to that particular lens and be able to adjust for the motions that can exist within that lens better than they can if you're always adjusting motion that exists within the camera. And to put this another way, you can imagine that if you have a very, very long lens, for example, and you are trying to counteract its motion by moving the sensor, it may not be as effective as it would be, for example, on the opposite end with a wider focal length. So while it may give you some benefits, it will give you the benefits of being less expensive and also being omnipresent in basically all of your lenses that you put on there. It's not going to perhaps be as effective as these in-lens systems. So you have to, again, pick your poison. You can have a more expensive system and have the best quality available by having them all in the camera, or you can have a less expensive system that maybe doesn't work as well and put it on the sensor. But there's another reason why you might want to have image stabilization in the lens itself. And that is that light, remember, if you follow the path of light as it enters your eye, it goes into the lens, bounces off the mirror before it goes into the viewfinder. So that means that if you have image stabilization in your lens, you will be able to see the image stabilization as it's happening as you are using the camera. And if you've never used an image stabilized camera before, or rather an image stabilized lens, it's actually something that's really neat to be able to do, because you're holding it and it's obviously like shaking a little bit, and then when you turn on the IS, it's just all of a sudden becomes really smooth and really sharp, and it's really neat, and it's a really neat way of being able to help you remove that stabilization out of your viewfinder and get you to focus on the image itself. So that's certainly one other way that this can be helpful. Now, another thing to keep in mind is that using a tripod might be detrimental to some image stabilization. So if you have already stabilized the camera enough, you may want to turn IS off, because sometimes it will still try to correct for motions that don't exist, and you will sometimes get this really weird streaking of light that exists. In fact, I accidentally left IS on this camera when I was taking photos, if you remember, from that very compressed El Paso photo. And it was a little bit later, and it was a little bit darker, and I left IS on, and it was just a complete streaky mess. All the lights had been blurred out of to oblivion because I left IS on. So you might need to turn that off. Now, some image stabilization systems also have different modes available to you. So, for example, if you wanted to take a photo that is of motorsports, for example, where you remember that there was that photo of the car where the car itself was in focus but everything else was blurry. Now, you can imagine that when you're taking a photo like that, you're panning the camera along with the car itself. And if you have IS on, you may not want it to operate on the horizontal axis, because it might try to fight you, so to speak, as you move the camera left to right. Might try to correct for that, and you could get some weird effects. So some cameras, or rather some lenses, have additional modes that allow you to turn IS on certain axes only, so that you can say enable it only on the vertical axis so that you can get very nice horizontal pans like that, or you could have both axes and be able to really stabilize image in that way. Now, image stabilization is really neat, but remember that like I said, that it's really not a good replacement for very large aperture lenses. It's definitely a good complement to it, but it's certainly not very good as a replacement for it. Now, if we continue talking about some optical technology, you'll notice that I mentioned tilt-shift lenses before. Now, one of the things, I don't want to talk a lot about them because I don't think many of you will actually ever used tilt-shift lenses, and it's because of how expensive they are, but you can have some neat effects with them. You can actually dramatically change the way that the depth of field can occur in a particular image. So this image looks like a model, but it is actually real. It's actually a real scene. It is actually of a highway with cars on it. But with using a tilt-shift lens, they've been able to exaggerate the depth of field so much that it makes it look like a macro shot. It makes it look like it's only a shot of some models. And if you use, for example, the shift portion of the lens, what you can do is eliminate some of these perspective problems, these perspective converging lines that can occur, especially with architectural photography. If you're an architectural photographer, you will have to probably consider using one of these lenses because of how useful they are for that. And so it doesn't make a lot of sense, at least initially, why you would use shift and not the tilt portion to fix this. But rest assured that this is actually what you want. You want to use the shift portion to be able, you're essentially shifting the lens up, and that way you're able to get it to be a bit straighter. You're altering where the horizon is on that particular image. And what shift is used for is to, or rather what tilt is used for, is to actually tilt the focal plane against against the lens plane, and you can alter not only its depth of field, but well, you will alter its depth of field. So you can either get a lot in focus, so you could, I mean, besides the hyperfocal distance, you could even get, even with a very low f number, a lot in focus. So this is very good also for landscape photography. Or you could go the other route as well and make it look like what you're taking photos of are models. Now, very quickly, I did want to address filters as well. And so one of the things that you'll remember is that the filter size symbol looks similar to the focal plane symbol. It's just tilted a little bit. And so there are some filters that are very useful to us. So for example, neutral density filters. Now what this filter will do when you put it on top of your, or on the front of your lens, is it essentially acts as sunglasses for your particular camera. And what it does is, as sunglasses, let's see, do I even have it here? What it does is it just makes the scene darker. And what that means is that you can have a slower shutter speed for a higher amount of light. So here's a neutral density filter, for example, and it just looks darker. And that's all it really does, is it just makes the scene darker so you could have longer shutter speeds available to you so that you could get, for example, motion blur within an image that's, you know, at the brightest point of day. And this is helpful even if you have the lowest ISO possible and the highest f number possible, and you're still getting a really fast shutter speed. You can use a neutral density filter to try to help combat that. So that's if you want motion blur in your scene at all. And so typically they come available in filter factors. This one is called an ND4, for example, and that means that I'm dividing my shutter speed by 4. I'm making it 4 times slower. And in retrospect, I should have bought a higher power, because the only time that I really need it is when I want really long shutter speeds. I think ND8 or even higher, if possible, would have been even better to get. Okay, now there are other filters available as well. So there's something called a polarizer filter as well. And specifically a circular polarizer. So there's linear polarizer and circular polarizer. Do not get anything but a circular polarizer if you were going to get one. Linear polarizers can have problems with autofocus in some cameras, and it's just not something that you want to have to deal with. Most of these filters now are circular polarizer, but you still want to be sure that you're getting the correct one. You don't want to get linear. Now, if you have polarizer sunglasses, for example, you may know what this effect does. It actually will increase or alter the amount of contrast within the scene. And in fact, if we take a look at this photo, which is kind of boring, and we take a look at this next photo, this is with the polarizer, you see that it has changed the appearance of the colors. It has changed the contrast within the scene without doing anything, not waiting for the light to change, without doing anything other than just attaching the polarizer. So just going back and forth, you can probably see the difference. No polarizer and polarizer. Now, one of the other things that polarizing filters will do is alter the way that you view reflections. And in particular, if you have a very heavily reflected region, you can use a circular polarizer to actually remove those reflections and be able to see something underneath it. So this is useful in water or, for example, glass. If you're trying to take a maybe an automotive photo, for example, and you want to try to eliminate as many reflections as you can off of the windshield or off of the side window, you can use a circular polarizer and you twist it. You basically twist it until you get the exact point that allows a certain amount of light in and the reflected light out. And the reason that this works is that when light reflects off of something, it becomes polarized in a particular direction. By using a polarizer, you're able to just eliminate some of those polarized regions of light. And so there's other filters available as well, like a haze UV filter. And I'm just going to say it, I think they're useless. I don't think you need to buy them. The reason for that is that a lot of people like to use them for protection for their investments. If they buy a very expensive lens, they want to put just some piece of filter, some piece of glass in front so that you can protect the front element from dings or from cracks or from something like that. But there's two major downsides to this. The first is, well, three, I guess. The first is cost. You have to spend money to buy a good filter. And tangentially, if you're going to buy a filter, you should buy one that's multi-coated, because it's really silly if you buy a really cheap filter and you have a really expensive lens and you put something that's going to reflect a lot of light or do a lot of disservice to your lens. So you should buy a multi-coated lens for your, or rather multi-coated filter for your expensive lenses. Okay, so with haze UV filters, first you have the cost that you have to pay for. Next, anything that you put in front of your lens is going to decrease the amount of light entering into it. No matter how clear the glass is, I don't care how clear it is, you're decreasing the amount of light that's entering into it. You know that glass is somewhat reflective. Some of the light is being bounced back. Some of it is just not being transmitted through. So you're losing some light available to you whenever you put it on. The third thing is that as a protection scheme, I think that's a bunch of crap, frankly. And let me show you what I mean by that. So let's say that we have a lens and it looks good, okay? And we take a photo that looks like this. It's a pretty clear photo. It looks pretty good. Now, let's say that we start dirtying the lens a little bit. So we put a little bit of dust in front and let's see, what's wrong with this? I think they just put a little bit of dust. It's kind of hard to see right here. There's some dust and some other stuff. Then they take another photo and you see that there's nothing wrong with the photo. Okay, now what they do is they put pieces of masking tape in front of the lens and they try to actually mask some of the light that's entering into it. All right, well, you know what? Still looks the same. You can't tell. All right, so now let's go a little bit stronger and let's actually crack the lens, okay? Drop the lens, break it completely, take a photo. It looks like this. Now, for the most part, this is kind of still usable. If you're in a bind and you can't replace the lens, it still works. And it's not just this website. You can Google around. You will find so many examples of this happening that I don't think it's worth it. So don't waste your money. Don't waste your time on these haze UV filters. Just go for it. And if you're careful, you can actually continue taking good photos. And in fact, if you take a look at some of my lenses in the front, they're pretty well used. They have, fingerprints, they have dust on them. They frankly work the way that they always did. What's more important, you should keep the back of the lens as clean as you possibly can. That is what matters. The front of the lens really doesn't. But with all of that said, thank you for coming, and we will see you in 2 weeks. I think next week we actually have a holiday. So in 2 weeks, we will see you back here.